Hello class, this is Mr. Roberts at Shasta High School, and today we're going to be looking at section 9.2 in our textbook. And we start with this question that has 6 inequalities that we're asked to find solutions of. And remember, when we're solving an inequality, we're finding all the values of x, m, p, x, whatever the variable is, that make that inequality true. And honestly, for the most part, when you're solving an inequality, it looks a lot like solving an equation. There's one situation that we need to be aware of, and we're going to look at where that pops up and how we can try to avoid making the mistake of not noticing when that happens. So, what we outlined yesterday was kind of this three-step process for solving an inequality, and we might want to look at this first one. It's x minus 7 is less than negative 2, and think about that process. So the process involved these steps. First of all, it says solve an equation to find the boundary point. So when we look at our, I just forgot what it was, x minus 7. If I look at x minus 7 is less than negative 2. Let me hope I got that right. X minus 7, yeah. If I look at that, right, it says, hey, forget the fact that it's an inequality. Just go ahead and solve it as an equation. So I'm going to write x minus 7 equals negative 2. And when I solve that, I get that x is 5. Now, that's not my solution. In fact, that point doesn't even work. What that is it's the boundary location. It's the point where everything either to the left of that point or to the right of that point is the solution. So we found the boundary point by considering this as an equation, and we found that location. So if I was going to mark that then on a number line, here's the number 0, and here's 1, 2, 3, 4, here's the number 5. Another important thing to note is because this is strictly less than, it's an open boundary. So remember from yesterday, we have these 4 different symbols, right? We've got less than or greater than, where we're using open boundaries, and then less than or equal to or greater than or equal to, where we're using closed boundaries. And the difference being is that if it's got the or equal to, it includes that point. That point is a solution. So we've identified the boundary point, and we've marked it on a number line. It's here at positive 5. Our question is, do the values above that point or do the values below that point work? My favorite number to check, if it's available, is 0. And if I take the number 0, what I'm doing is I'm testing the left-hand side, right? I'm testing here, and I'm saying, because I'm using 0, I'm saying, hey, do the points below 5, or do they act as solutions to this inequality? So if I plug the 0 into there, I get 0 minus 7, which is negative 7, and then that is less than negative 2. Is negative 7 less than negative 2? Absolutely, that's true, right? So because that's true, I know that that side is the side that includes my solutions. So my solutions is not 5, but everything less than 5, everything this direction. And if I was to write that, I would say my solution is x values are strictly less than the number 5. Any x value that's less than 5 works. So that's the solution process that we've talked about, right? Solving it as an equation, finding the boundary point, open or closed, depending on whether or not it's got the or equals to or not, marking the boundary point, and then testing on either side and seeing which side works. Interesting fact, I just showed you that the points below that boundary did work. Any point I picked above it wouldn't. For example, if I put the number 6 in there, this would become 6 minus 7. 6 minus 7 is negative 1. Negative 1 is less than negative 2 is false. Negative 1 is larger, right? Negative 1 is to the right of negative 2. So any of these points right here are going to fail to be solutions, but any point over to the left of it will be solutions. So that's where we're at so far, right? Now, I recommend this testing apparatus a lot, right? It helps avoid errors, and if you're concerned about making a mistake, and just even fundamentally, just once you get an answer, just kind of checking to see, is this really the answer I intend? Because there's situations where this doesn't. I mean, this will always work, right? But if you were just to bound along and say, forget this regimen of finding the boundary, marking the boundary, and testing. I just want to just pretend like it's an equation and forget about it, right? There's points where that will cause a problem. In fact, D is such a problem where just bounding along is going to cause an issue for us. So let's go ahead and do D together. And in this time, I'm just going to say, you know what? Forget it. I'm not going to do this whole regimen. I'm just going to follow along and just kind of treat it like it's an equation. But as I treat it like it's an equation, I'm just going to go ahead and solve the inequality. So I could say 2 minus 3x plus 3. So the first thing I did right there, if you look, yeah, I distributed this negative 3 to both the x and the negative 1. So this became, on the left-hand side, 2 minus 3x plus 3, and this is greater than or equal to x minus 7. All right, so the next thing that I guess I'm going to do is I'll combine the 2 and 3. So I've got negative 3x plus the number 5 is greater than or equal to x minus 7. I'm going to take away an x from both sides. When I take away x from both sides, it's going to become negative 4x plus 5 is greater than or equal to negative 7. I'm going to subtract 7 from both sides. So that's going to give me a negative 4x, right, is greater than or equal to the number negative 12. And then finally, I'm going to divide both sides by negative 4, and I get that x is greater than or equal to 3. So the problem is in this last step, right? This is a lie that I told, and I told with some boldness. Like I'm just like, ah. And I want you to think about this for a minute. Let's think about this lie and think about maybe shortcuts we can use to avoid making this mistake, and not going through the whole testing regimen. Well, let's just, for example, if I was to pick a value right now greater than 3, like clearly the number 5 works, right? 5, the number 5 is greater than, it's greater than or equal to 3. So if I was to test 5, according to my solution, 5 should work. But when I come back up here and I plug 5 in, so we're going to say that this x is going to become a 5, and this is going to become a 5. If I evaluate the parentheses, 5 minus 4, 5 minus 4, I'm sorry, 5 minus 1 is 4. This becomes the number 4. 5 minus 1 is 4. Times negative 3 is negative 12. So this is 2 minus negative 3. It's a 3 times 4 minus 12, right? 2 minus 12, and then greater than or equal to 5 minus 7. Well, 5 minus 7 is negative 2. And on this side, I've got negative 10. So let's write that down big, right? I'm saying negative 10 is greater than or equal to negative 2. This is false, right? So my solution is a problem because it's not giving me the right x values, right? It's giving me the wrong side. Now, here's what happened, and I want to show you this kind of in slow motion. Here's what happened. Here's what's caused our issue. Our issue is caused by the fact that at a certain point, let's just say I have this is a true statement. 5 is greater than 2, right? We all believe that, right? 5 is larger than 2. Probably let me do a different number. I'm going to say 15 is larger than 6. That's certainly true. 16 is larger than 6. If I divide both sides of this, if on my next step I divide both sides by negative 3, that's going to give me on the left-hand side a negative 5, and on the right-hand side it's going to give me a negative 2. Well, you can see this whole thing just flipped over, right? It is now no longer the case. Negative 5 is not larger than negative 2, right? Negative 5 lives right here on my number line. Here's 0. Here's negative 2. Negative 2 is larger. So here's what's happening if we slow roll this. When we divide both sides of this, right? When we divided both sides by negative 4, this whole thing flipped around. It pivoted around this 0 point, right? And what should have happened was the direction of my inequality should have flipped. Now, it turns out that if you're very, very careful and you pay attention to this, if you divide or multiply both sides of an inequality by a negative number, the direction of this inequality symbol has to flip around, right? Necessarily. And it's true for arithmetic, but it's also true for algebraic expressions. So like here you can see this was an algebraic situation. I divided both sides by -4 and I got what turned out to be a lie. Right? This was a lie. Now again, treating this as an equation, finding my boundary point, testing left or right, and then using that information to decide where my solutions are, that's always going to work. This works too if you're just really careful and you notice if you're whenever you divide both sides by a negative number. So what we're saying here is like 3 is clearly greater than 1. If I multiply by -1, -3, -1, it turns out that -1, this is now larger. Oh, okay, I see. What's smaller here? -7 is clearly less than -2, is it? Yeah, -7 is way to the left on the number line. -7 is less than -2. If I multiply both sides of that by -1, I get 7, I get 2. You know what? The bigger one now is the 7, right? So if we can really pay attention to our work and think about this phenomena of when we multiply by a negative number, the whole number line flips around, it pivots around 0, or 2 points, then we can avoid that error. So most of these problems then fall in line. They're pretty straightforward. There's a couple things that probably are worth noting. Like on B, for example, when we solve B, you might take away 3m from both sides. So I would get 5m. So I'm doing B right here, right? Forget about E right now. I get 5m minus 8 on the one side is less than or equal to, and that just becomes a 2. Add 8 to both sides, this is 10 is less than or equal to 5m. And then if I divide both sides by 5, I get a 2 over here. Now, we would never write about this because I'm not asking about 2, I'm asking about m. So what I would expect for you to write for your answer, look at m is clearly larger, right? I would expect you to say, oh, the m's are greater than or equal to 2. M values that are larger than 2 or equal to 2 work. And I hope you can see that the difference between this answer, which is still fundamentally the same, and this one, right? I want you to tell me about the variable I'm asking about. I'm not asking about the number 2. I'm asking about m. So make sure that we state our variable like that on the one side. Some of these statements, like if you look at this right here, 3y plus 1 is less than 3y plus 1. Nice. Nice. If I take away 3y from both sides, I get 1 is less than 1. Well, it turns out that's always false, right? The number 1 is never less than itself. Now, if that was less than or equal to, sure, that would be fine, right? That would always be true because it is equal to it. But 1 is less than 1. No, there's no solution there. So that's it. That's pretty much what I wanted to talk about today. I think that you guys can look at these other ones and figure them out. So let's move on to our next problem then. The final problem I want to talk about today from our text is question 15. And I don't really care about this whole at the end of the chapter thing because I don't know that we're going to be doing that. But I do care about is just this statement here. And I want to look at just this. So it says, write and solve an equation that represents the problem below. Be sure to define any variables you use. Now, you guys are some of the smartest people I know, right? You're honors math 1, and I believe in your abilities entirely, right? So because I'm talking about this problem doesn't mean I don't believe in you. I just want to help make sure that you follow the directions here and have a thorough reading of this problem before you just bound into it. So there are a total of 193 member states, countries in the United Nations as of 2014. The member states are divided into regional groups, and you can see some names of the regional groups. There's an Asia group. It has one less member than the Africa group. Okay. The European groups are smaller. Eastern European has 4 less than half the Africa group. So this is the European group, but they're using the African group as a reference point. The Western European group, which includes the United States, has 6 more than the Eastern European group. Okay, so there is the so I'm wrong. There's a Western European and there's an Eastern European group, right? So maybe I'm not going to talk about the European groups because there's more than one of those. There's a Latin American group. Okay, there's a Latin American group. There's one less than the African group. And the one country, Kiribati, in the Central Pacific Ocean, is in no regional group at all. Oh, so there's this one that's all by itself. So of the 193, right, there's a +1 for this group right here. So just looking at this and thinking of it, because the Africa group shows up so much, right? The one thing that I want you to do is I just want you to write I just want, oops, nah, let's turn off that shape thing. We're just going to write let A be the number of countries in the Africa group. Now, if that's true, right, if that's true, we can go through and we can define the Asia group, we can define the Western Europe group, the Eastern Europe group, the Latin American group. We can define all those groups in one way or another in terms of this single variable A. And when we take all those expressions, right, we're going to have an expression for the Asia group, an expression for the Western European group. Then we're going to use that Western European group together to get the Eastern European group, and then the Latin American group. And then finally, we're going to add the Kiribati there. All those are going to add up to 193. So what I want you to do is I just want you to solve this. And in the lesson check, I'm going to be asking you these questions, right? How many countries are in each of the 5 groups? Right? How many countries are in each of the 5 groups? So before you go on and proceed with the lesson check, spend some time working with that, and you're correct if you add the Asian group and the African group and the Western and Eastern European groups, the Latin American groups, and you add Kiribati to that, you get 193, right? So if all those internal relationships are there, right, and when you add them up, you should get 193. So take some time to do that. If you want, it's totally cool if you call up a friend and say, hey, let's look at this problem before I proceed. But then go ahead and move on, do the lesson check, and then, of course, the homework for tonight. This is Mr. Roberts. I will see you again tomorrow.